oftentimes in your render loop, so that you can cache those targets and then use them inside of your code. And that's what we're going to talk about in this section here. Now, to actually get information from the tracking system, you're going to need to get the tracker target. Now, there are multiple tracker targets potentially inside of a tracking system. To get the one that's currently associated with the head, you're going to use this function here, which is get default tracker target with the type being head. And there's configuration files which allow you to switch around which tracker target is associated with which type of target that the system knows about. But for the head, you're going to use type head. Once you have this target, you're simply going to call get pose on that target, which will return you the head pose in a matrix 4 object. Near the end of this talk, we'll talk about how you can extract more detailed information out of this matrix 4 object. But for our case here in head tracking, since all we want to do is have the stereo code take into account that head position and orientation, all you need to do is grab your stereo frustum object and set the head pose with the one you just read. And I know this might seem a little bit sort of strange to actually just grab information from one system and pass it along to one of our own systems. Our simplified C interface does a little bit of this for you, but the main purpose for it doing it this way was, again, we wanted to have that orthogonality. We wanted you to be able to use the tracking system and maybe not our stereo system, or a stereo system and not necessarily the tracking system. It totally depends on what you want to do in your app. So this will basically get you head tracking in our system. So we think it's actually pretty easy.